everyone. In this video clip today, I'm gonna talk about three sections: 3.1, 3.2, and 3.3. Pretty much in this three section, I will provide to you guys the basic formulas for taking derivative and two very popular rules called the product rules and the quotient rule to do derivative. So first, let's start with the definition. Definition of derivative is what? F prime of x is the limit of f(x) plus h minus f of x all over h when you take h approach 0. Okay? The reason why I brought up the definition here is all the formulas, if you ever wonder how we found the formulas, is all based on the definition. We calculated, we found the formula from definition. But we are getting tired of every time we need a formula, we go back to definition and prove it. We don't need to prove it anymore as long as you memorize the formula. So from now on, if you get the formula, your life's going to be a lot easier. Apply the formula, you can find derivative. Before moving on, let's talk about notation. Our traditional notation is f prime, right? And it's called derivative. But there was a mathematician, his name is Leibniz. He invented new notation to represent derivative, which is very, very useful later on when you guys do derivative, especially for a implicit derivative. So there's another notation of the derivative. Instead of writing f prime of x, you can write this way: df over dx. Okay, it means what? Differentiate the function f with respect to the variable x. Okay, changing of f over x. Or people can write this way: d over dx of f right here. Okay, same thing. So I'm trying to use both ways. Our traditional notation f prime for derivative, or Leibniz notation for derivative. Okay, so let's start. Let me erase this. Derivative of a constant. C is a constant, okay? Derivative of constant is equal to 0. See, I'm using the traditional notation in here. C is a constant, I take derivative. Let me just go right this way: dc over dx. Okay? Derivative of x is equal to 1. And of course, notation will be dx over dx. It's 1. Okay? Now, general formula for those actually polynomials of x to the n, called the power rules. Okay, derivative is n times x to the n minus 1, and limit notation of it is d of x to the n over dx. Okay, so actually this one covers the upper two. Those are special and kind of trivial. Usually, many people tend to forget the trivial cases, so I'm writing more out. Okay, so pretty much the formula say what? If you have a function f of x equal to x to the 5th, and you want to take the derivative of this, you don't need to use a definition anymore. 5 on the exponent, right? Bring the 5 down, and then times x to the 5 minus 1, which is 5 minus 1. So this is 5 times x to the 4th. You lower the degree by 1 unit, and you multiply everything by the exponent originally. So 5 times x to the 4th means derivative of x to the 5th. How about this? X to the 7th. Derivative of x to the 7th, when you limit the notation in here, it's going to be 7 times x to the 6th. Okay? I brought the 7 down and I lowered the degree, the exponent by 1. Okay? And by the way, this formula is true for any kind of number, and could be positive, could be negative, could be decimal. So if I got like x raised to the 1/3, derivative is 1/3 times x to the 1/3 minus 1. You see, when we bring the n down, so 1/3 in here, and then x to the 1/3 minus 1. This is equal to 1/3 times x to the negative 2/3. Okay. Let's recall something that you learned before. I showed you guys in the example. Say f of x equal to square root of x. Derivative, I showed you this in the clip, is 1 over 2 square root of x, right? Let's apply the formula in here. I'm going to rewrite it as f of x equal to x to the 1/2. Square root is the same thing as 1/2. Now I can apply the power rule right here. Derivative f prime of x, bring 1/2 in front, times x to the 1/2 minus 1, which is 1/2 times x to the negative 1/2, and this is no more than 1 over 2 square root of x. See, same thing. Now you have this powerful rules with you in the pocket. You can calculate derivative pretty quick on many problems. Okay, more. If you have a constant time of function f, and you take the derivative of the whole thing, it is the same thing as c times f prime only. Means what? Whenever you have a constant time of function, you can leave the constant alone and then time the derivative of f. It's different from here, okay? It's just a constant by itself. It's a constant time of function. Okay? And say, for example, f of x equal to 7x to the 4th. So I have 7 times x to the 4th. So the derivative, f prime of x. I'm going to leave 7 alone. I'll take the derivative of x to the 4th. Derivative of x to the 4th, apply the power rule right here, is 4 times x to the 3rd. And now I simplify, I got 28 x to the 3rd. That's with the derivative. Okay. More formulas. Derivative of the sum, f of x plus g of x. Everything you take the derivative. It's going to be the derivative of each function. Oh, right here. Derivative of the sum equal to the sum of derivatives. And same thing if you have subtraction. Okay, example. Say f of x equal to x to the 7 plus x to the 4th. So f prime of x is going to be 7x to the 6 plus 4 times x cubed. I take the derivative of each term at a time. One term at a time. Okay. The derivative of, it's all about polynomial. Let's move on, more formula. Exponential form. Derivative of e to the x is just e to the x. It's the easiest one. Okay? A little bit more general, if you got a to the x and you take the derivative, it's going to be a to the x times ln of a. We'll be talking about that later when we learn about chain rules. Okay? And the derivative of ln of x, let me change the marker, it's out of ink. The derivative ln of x is 1 over x. In general, log base a of x, derivative is 1 over x times ln of a at the bottom. Okay. Let me check the book, see if I missed any formula that they gave you. So I gave you more than what I gave you. Okay. Now I'm going to talk about some formulas for trigonometry function. So sine of x, derivative is cosine of x. Derivative of sine is cosine. See, I'm using the traditional notation of the derivative. If you want to write in terms of Leibniz, then that one is very helpful, okay, very useful. You can write this way, same thing. D of sine x over dx, okay, or you can write this way, d over dx of sine x, either way, which is the same thing as sine x derivative, which is equal to cosine x. And I don't want to waste time writing two ways of the same things over, so I'll just use traditional notation, but you can always bring it back to Leibniz notation whenever you like it, okay? All right, derivative of cosine of x is negative sine x. Derivative of tangent of x is secant x squared, secant square of x. Okay, derivative cotangent of x is negative cosecant square of x. Okay, derivative, let's say, derivative, okay. Derivative of secant x is secant tangent. Secant x times tangent x. Derivative cosecant x is negative cosecant x times cotangent x. Alright. So how do we remember all of those? Simply practice, guys. Do some exercises and it's going to be yours. Let me look if I miss any formulas. Oh, that's it. Now I'm going to talk about the two very useful rules that you guys are going to use when taking derivative, called the product rules and the quotient rule. Okay. Let's start with the product rules. Product rule is this. You have two functions times each other, f of x times g of x, and then you take the derivative. And the formula is this. F prime of x times g of x plus g prime of x times f of x. So if you have product of two functions, derivative product, derivative first times the second plus derivative second function times the first. So this is a long way of writing. Let me put it in short. If you got a u times v, okay, and then take derivative. U step of f of x and v for g of x. It looks easier if I write this way. It's u prime v plus v prime u. If this is any better, it looks shorter, right? Less work, less writing, and it's clearer. So this is the product rule. Example. Say I got a function that looks like this. How about f of x equal to x cubed times sine x. You see I have two parts, two factors for the f of x function. X cubed is one term and sine x is another term. Now I want to calculate the derivative of f. I'm going to apply the product rules in here. The derivative of the first is 3x squared times the second part is sine of x plus the derivative of the second part, the derivative of sine is cosine x, and time the first part, which is x cubed. And usually people write this way, 3x squared sine x plus x cubed cosine x. Okay? Try another example. Say I got f of x equal to 3x squared plus 5x times x cubed plus 4x. Okay? You guys see that I have product two factors. The first factor is 3x squared plus 5x. Think of this as like a u right here, and then x cubed plus 4x like a v right here. And I want to calculate the derivative f prime of x. Of course, if you don't know the product rules, with this problem you can also take care of it as well by factoring everything out. You have a polynomial and then take the derivative one term at a time. But in here, I'll show you the product rules, or I'll use the product rules. Derivative of the product is what? Derivative of the first times the second, right? Derivative of this first part right here is 3x squared. Derivative is 6x. Remember the power rule, bring the 2 down. 2 times 3 is 6, and x plus the derivative of 5x. X, the derivative is 1, so 5 times 1 is 5 times x cubed plus 4x. You see what I'm doing right here? This is u prime times v. Now I'm going to add v prime times u. The derivative of v is 3x squared plus 4 and times u, which is 3x squared plus 5x. Okay, this is v prime times u. I have the product rules. Okay, now let me talk about the quotient rule. Alright, so f of x over g of x, now you take derivative, is f prime of x times g of x minus g prime of x times f of x all over g of x squared. Okay, this is a formula. Let me just write it in short. If you got like something like u over v in general, okay, take derivative. It's going to look a lot nicer in my opinion. So u prime times v minus v prime times u and everything over u squared. V squared, I'm sorry. Okay, the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom square. Okay. Example. How about e to the x over x squared? This is my function f of x, and I want to calculate the derivative of this. So f prime of x, I have to use the quotient rule. Okay, the derivative of the top, the derivative of e to the x is just e to the x, and times the bottom is x squared minus the derivative of the bottom times the top. Right, this e to the x, the derivative of e to the x is just e to the x already. Bottom is x squared, the derivative is 2x times e to the x, and everything divided by the bottom square. X squared, everything squared, and you simplify, you got x squared e to the x minus 2x e to the x, everything divided by x to the 4. 2 times 2 is 4. Okay. Recall the formula before e to the x, the derivative is the same thing, e to the x, so we have this. Okay, try one more example. Simple case. Say I got f of x equal to sine x over x cubed. Fraction, right? So quotient rule. F prime of x. Apply the formula right here or right there. Same thing. Derivative of top times the bottom. The derivative of sine is cosine. So cosine of x times x cubed minus the derivative of bottom times the top. The derivative of x cubed is 3x squared times sine x, and everything divided by x cubed, everything squared. Now let's simplify. It's going to be x cubed cosine of x minus 3x squared sine x, everything over x to the 6. Okay? So, in this video clips, I show you some basic, very basic derivative formulas about polynomials, about multiply by constant, power rules, and then show you two popular rules called the product rules and the quotient rule. And you guys can apply those formulas to take the derivative of a bunch of basic functions. Okay? Hopefully, if you have the video clips, you have enough information. Make sure that practice enough exercise is going to help you to learn the formula. Thank you for watching, guys.